Hello and welcome to Wagner Academy as we start Chapter 3 with parallel lines and transversals. This chapter, Chapter 3, all about lines and what happens when they intersect, stuff about especially parallel and perpendicular lines for this chapter. Here's some new terminology for this lesson. Make sure you understand that stuff by the end of the lesson and make sure you use those extra examples in your book. Let's see what we got here. So 3.1, coplanar lines that do not intersect are called parallel lines. And let me just change the width of my pen. There we go. It's a little better. They're called parallel lines. Make sure you spell that right. I see this misspelled a lot. So P-A-R-A-L-L-E-L. Similarly, in 3 dimensions, two planes that do not intersect are called parallel planes. So you can have parallel lines, you can have parallel planes, you can actually have parallel rays, parallel segments as well. The symbol, if you draw what basically looks like an 11 or a double L, but this would be a little bit taller than that here and here, that means is parallel to. So that's our symbol to quickly write that. And if you would prefer to write this on a slight slant, I'm going to be alright with that too. That's actually what I'm a little more used to, but our book uses this instead. So we can say this symbol, or you could say that on a slight slant. So you might see me using either one of those. And arrows are used to indicate that lines are parallel. So I'm not talking about the arrows at the end of the line. That just indicates that it's a line that continues forever in both directions. I'm talking about an arrow on the line itself. So on this diagram, I want you to draw in two arrowheads on these two lines. Those arrowheads would indicate that line AB is parallel to line CD. And so let's write that down underneath that. Line AB is parallel to line CD. That's how we would read that out loud. So that would be true because the arrowheads are there. If the arrowheads weren't there, you couldn't say that. Even though they might look parallel, we can't assume things are parallel unless we're told that they are. So I'm telling you in this picture that they are, therefore we can say that. And lines that are not coplanar, so not on the same plane, and do not intersect are called skew lines. There's a really fascinating documentary about this guy, Philippe Petit, back in 1974. It's called Man on Wire. He actually, with a small crew, they snuck into the World Trade Center towers before 9/11. Back in 1974, actually, they snuck up there. They got a tightrope connected between the two towers, and he walked across it on the tightrope, and everybody was watching him. Became world famous after that. And the reason I include that in this picture, or in this slide, is because this is an example of skew lines. So his balancing bar and the tightrope itself, those are not coplanar lines, and they do not intersect either. I want to make this full screen just a second. There we go. And so let's continue from there. So use the figure below. Name all the planes that are parallel to plane PRE. I'm going to highlight some things on the picture as I go here. Don't do that because I'm going to erase it immediately after highlighting it before moving on to the next question. So just watch what I highlight over here, and I think you'll find that useful as we discuss what's what. So here's plane PRE. It's this plane right here. What plane is parallel to that plane? Well, I would say that this plane over here, if you extended those planes out forever in both directions, they would not intersect. So plane PRE and plane, you could use any of these 4 letters. You have to use 3 of those 4 letters. I'm going to go with CTM because I actually have some videos on Wagner Academy about a class I used to teach called CTM, called Contemporary Topics in Mathematics. Check the videos out if you'd like to. It's kind of like a survey in mathematics course. We got all kinds of different various topics that rarely get taught in a typical high school curriculum on there. So plane CTM, this plane and this plane would be parallel to each other. If you extended them out forever, they'd never touch. Part B, name all segments that intersect CT, segment CT. So here's segment CT. Where's my highlighter? There we go. Back to that. So here's segment CT. Which ones intersect that? Well, it looks like I have this one, this one, this one, and this one. They all cross either at T or at C. So what are those written out? It looks like that was 4 different segments: RT, EC, TM, and CS. Part C, name all segments that are parallel to IS. Let's see where IS is. Here's IS. So parallel to IS, that means if you extend the segments out, created lines, they would never intersect. So clearly not going to be, I'll do this in red. These are ones that wouldn't work. These lines would not work if we extended them out, because the segments themselves touch IS, so not parallel there. So those ones not going to work. I'll go with green for this now. These ones are going to work. Green means go, right? So this one, and this one, if we extended them out forever in both directions or in all directions, those would never cross line IS. And so the segments that are parallel, it's all those ones. So I've got EC, RT, and PM. I think I can use my eraser tool just to get rid of that. Yep, beautiful. All right. And finally, name all segments that are skew to TM. So skew to TM, let's highlight TM a moment. Here's TM. So these are segments that if you extended them out forever, that would never touch and are not coplanar at the same time. So it looks like CS, they would never touch with TM, or that line would never touch with TM. However, it's coplanar, it's on the same plane, so that doesn't count. That's why I'm marking it in red over here. PR and EI, the same thing. They are parallel, not skew. So they're on the same plane. If you were saying this one, it would be the front. If you were saying IE, it would kind of be the plane that cuts through the center or the diagonally across this rectangular prism. This is actually what we refer to as a rectangular prism in geometry. You might hear it more informally called a box. Yeah, that's what it is, but a rectangular prism is the more formal, fancy name for that. So all these lines extending out the segments would not work. So those ones, no go. However, these ones would be skew. So this line right here, IS, if you extend that out forever and TM forever, it's kind of like the balancing bar and the tightrope wire. They're not going to cross. If you extended EC out forever, same thing. And I think this one, yes, RE, if you extended that one out forever, they would not cross, and same thing with PI or IP. So those ones, all these segments would be skew in relation to segment TM. So let's finalize example 1 here. We've got RE, segment RE, we've got segment EC, we've got segment PI, and we've got segment IS. And so those, I'll put an and in there. I've been doing that. So and segment IS. So those are the 4 skew lines that I see with respect to line TM in this picture. A line that intersects, this is the next blank here, that intersects two or more lines in a plane at different points is called a, here's the other big word that we have in this lesson other than parallel lines, talking about transversal. So a transversal is just a line that intersects two or more lines in a plane at different points. For instance, in this picture, line G would be a transversal with respect to line L, M, H, and even N if you were to extend that up. We're going to talk about that. So I kind of answered one of our parts of this question already. Example 2, use the figure below to identify the sets of lines to which each given line is a transversal. So let's start with line L. We'll come back to G and write that down a little bit. But line L, as a transversal with respect to these given lines, line L would never cross line M. So it's not a transversal with respect to M. However, it clearly crosses line G. And again, I'm going to highlight some things here, and I wouldn't do that, but it'll just help us as we go along. So line L is what I'm looking at. Line M, not going to work, so because that will never cross if you extend those. However, let's see what it clearly crosses. Line N, it clearly crosses. Line G, it clearly crosses. Right here and right here. And then line H, it would eventually cross if we extended this out. So it's also transversal with respect to that line. And it looks like I only have those 5 lines. It's not to this one, and it is to those 3. So we would say that line L, if the lines were extended or are extended, let's write that down first, at least for this initial one. If the lines are extended, line L, and remember we're using script letters here, especially with the L. I won't get too hung up on these other ones if you don't use script letters, but with an L, otherwise write it cursive, otherwise it looks like a 1. So it intersects lines, and we got those in green here, G, H, and N. Lines, plural, there we go. Lines G, H, and N. So let me get rid of that now. And let's talk about line M now. Here's line M. It's a transversal, so it crosses which other lines? Well, it's going to cross. It's not going to cross L because it's parallel to that, but it is going to cross G, H, and I if you extend the lines out forever. It looks like you don't even need to extend the lines out forever in this one because it crosses right here, and right here with respect to those lines N, G, and H. So we have on this one, line M, I'm just going to write out what lines it is a transversal to. So this one is lines G, H, and N once again. Moving on, line G. We already talked about line G, but let's talk about it again, and I'll highlight some things, on the picture. So here's line G. Does it cross line L? Yep. Does it cross line M? Yep. Does it cross line H? Yep. Does it cross line N? Well, not in the picture, but if you extended it up here and here, it would cross up here eventually somewhere. So G, is actually a transversal with respect to all of the other lines listed shown in the picture. So I'm going to just I'll write them in alphabetical order here. Lines H, you don't have to write them out alphabetical order, but I'll just do that so I don't skip any. So lines H, L, M, and N. And likewise for line H, I'm just going to do this because I'm just going to switch these around. Now we're talking about line H. Does line H cross N? Yeah, it's going to cross down here. Does it cross M? Yep, it crosses right there. Does it cross L? Well, yeah, it will eventually out here. And does it cross G? Yep, definitely crosses G. So we have lines G, L, M, and N. So right now it doesn't really seem all that useful, but once we start talking about parallel lines, then we'll be able to say stuff about angles that are in different types of pairs with these things. And that's what we get to here in this last slide. We start to learn about transversals and angles and what we can say as we move on with this chapter, what we can say about those different types of angles, different properties of those angles with transversals. So I want you to draw a picture that looks something like what I'm drawing here. I'm going to get out my straight line tool and keep using blue. There we go. So draw a line like this. This is going to be our transversal, and then draw two other lines that this transversal crosses. That's what makes it a transversal. And I'm not going to draw them parallel right now. I'm going to draw them fairly close to being parallel, but not quite parallel. We'll talk more in the next lesson, especially about what it means if these lines are parallel. So let's call this P. Let's call this line Q. Let's call this line R. And so we're saying in this picture we have transversal P. That's the transversal we're looking at. Would Q and R eventually cross out here? Yeah, but we're looking at transversal P in this instance. And let's label these angles with a 1, 2, 3, 4 up here, and a 5, 6, 7, and 8 down there in that order. So the types of angles that I see in this picture, we have something just called exterior angles. And I'm not going to write the word angles after each one. I'm just going to write exterior and assume that's exterior angles. We have interior angles. So I think of exterior on the outside, interior on the inside. So with respect to this transversal, these angles, I'll go with green, highlighting in green again. These angles are on the outside of these two lines. So they're kind of, you see that, how they're on the outside? If these two lines make a sandwich, that sandwich has this on the inside, and it has 1, 2, 7, and 8 on the outside. I think that's a good way to think about it. And so this would be exterior. You could say angle 1, angle 2, angle 7, and angle 8. And then interior, that would be 3, 4, 5, and 6. Those are on the inside of the quote-unquote sandwich made by Q and R. So we have angle 3, angle 4, angle 5, and angle 6. Then we have something called consecutive, right? Somewhat small here. Consecutive interior, or consecutive interior angles. This one we have an abbreviation for, CIA. That's why I have Central Intelligence Agency emblem over here. This is kind of a sneaky one. We'll find more about what I mean when I say that in the next lesson. Why is CIA sneaky? Yeah, that's, oh, you just wait. You just wait, all right? It's up and coming. But angles 3 and 6, what would make angles 3 and 6 consecutive interior angles? So I'm looking at this angle right here and this angle right here. Well, they're on the interior, they're on the inside, and they're right in a row. They're consecutive to each other. That's why they're called consecutive interior angles. And similarly to that, we've got 4 and 5. These would be consecutive interior angles as well. So we have 3 and 6, and we have 4 and 5. So these ones come in pairs. The exterior and interior were just individual angles, but now these other ones are going to come in pairs. Okay. Oh, that's unfortunate. I forgot that that's going to erase. So I might just undo the highlighting quickly after I do it initially. So here, this next one, alternate, so on opposite sides, alternate exterior angles is another one. And while we're at it, let's just fill in the rest here. So this is AEA is an abbreviation that you can use, an acronym that you can use for that. Alternate interior. Guess what that abbreviation is, that acronym? Well, if you said AIA, very nice. And corresponding angles is this last blank down here. So corresponding angles, I don't have quite as nice of an abbreviation for that one. I'll keep with not writing angles. So corresponding is referring to corresponding angles. You can abbreviate that though like this if you want to. If you want to shorten that up a little bit, you could write CORR for corresponding, and then the angle symbol with an S for angles. So which ones are alternate exterior? Well, it looks like that would be, highlighter out again, on the outside, on the exterior of these lines. So we have 1, and then alternate to that would be on the outside of R, but on the opposite side of the transversal. So 1 and 7 would be alternate exterior, as would 2 and 8. That would be another valid alternate exterior pair. So let's write those ones down. We've got 1 and 7. And we have angle 2 and angle 8. Alternate interior, we could say 3 and 5, and we could say 4 and 6. Those are alternate interior angles. They're on the inside, and they're on alternate or opposite sides of this transversal. So those would work as pairs representative of alternate interior angles. So we have angle 3 and 5. And we have angle 4 and 6. And then corresponding angles, we would have, you could say 1 and 5. These are in the upper left-hand corner, you could say, with respect to these two lines that the transversal crosses. 1 and 5 are in the same relative spot. You could also say 2 and 6 are in the same relative spot. You could say 4 and 8, and you could say 3 and 7. So these are corresponding angles. They're in the same relative spot with respect to the transversal and the two intersecting lines. So we got 4 pairs for that one. That's why I left a little bigger space here for this final one. So we could say angle 1 and 5, angle 2 and 6, 3 and 7, 4 and 8. So in this final example, I've scrambled the numbers around a little bit so it doesn't match exactly with how you see it up here. But the idea is the same. You have a transversal and you have the two lines that the transversal intersects. So example 3, use the figure below to identify the type of each pair of angles. So I'm talking about these kinds of angles. 1 and 4, let's highlight those on my picture over here. Here's 1. Here's 4. Of the angle pairs that we talked about up here, that looks like it's alternate interior angles. It's on the inside of these two lines, and it's on opposite sides, alternate sides of the transversal. So alternate interior will work for this one. If you want to just write A, I, A, that is totally fine. If you want to write out the whole phrase, you can, but this is just as acceptable. 2 and 3, we've got right. Keep doing that. I got to select the highlighter first. There we go. 2 and 3 on alternate sides of the transversal, and now on the exterior of those two lines that it intersects. So 2 and 3 is alternate exterior angles. And again, if you want to abbreviate that, A, E, A. Looks like it went to part C instead of part B first, but that's okay. 1 and 3. It looks like, haha, I got it. Switch to the highlighter first. Switch back to the pen. That's in blue now. Good. You're getting better, Mr. Wagner, at that. All right, thanks. Corresponding angles. These would be in the lower left-hand corner, you could say, with respect to these two lines. And so corresponding angles would be the correct pairing for that one, the correct angle type for that one. And then finally, 4 and 6. I see that here and here, and it looks like that is a special type. That was consecutive interior angles. That was the two that are on the inside that are right next to each other. Boom, boom, there it is. So we've got, I did it again. 4 and 6 was CIA. Could you come up with more pairs that would be CIA? Sure. Could you come up with more pairs that are these other three? Sure. We just identified the ones that we were given. And that'll do it for us for this first lesson here in Chapter 3, talking about parallel lines and transversals. Again, watch that documentary sometime. Man on a Wire is what it's called, made in 2008, I believe. So it's a little dated, but not that dated. And about Philippe Petit, 1974 is when they did that, when he accomplished that feat. Oh my gosh, that would be so crazy, so scary to walk across the tightrope connected between the Twin Towers, or any skyscraper for that matter. Make sure you understand these terms now that we're done. Make sure that you're using those extra examples in your book. Make sure you're studying hard. Make sure you're getting ready for our next test coming up if you're one of my students. And make sure you have a good day. I'll see you later.